Good morning. We are going to look at the last example in 10.5, and which is really the basis of 10.5, part 2. I will also probably set up a couple of extra videos for you to look at for a couple problems that are worked out so that you can see how these work and have a better sense of them when you go through your homework. These will be optional. And don't forget, I also have some occasional help sessions. So I'm trying to help you with some of these. If you get it quickly, you won't need to do it. And if you do need some extra help, I would look at them. I'm also going to attach some videos from Khan Academy, which will help you with some of this as well. They have a lot on completing the square. All right, so let's look at 10.5, part 2, example 4. And this is putting blackboard paint on a door. All right, let me draw a door. And this door is 7 feet long, 3 feet wide. And what I want to do is I want to draw or to paint a smaller rectangle on my door out of blackboard paint. But I'm told I'm limited to 6 square feet worth of paint. The label on my paint says we'll paint 6 square feet. And I know I don't think that's going to be my whole door because 7 times 3 is 21. And so how am I going to get my much smaller blackboard on my door evenly so it looks good? Hopefully even better than my drawing, which is not thoroughly even. To make it even, I need a nice border X wide all the way around. And how do I find what that number is? Well, you start with what you know. And what we know from past history is A is length times width, right? And so I know the length and width of my blackboard here, and I'll do it in green just so we can see where we're starting. That area has to be length times width. And my length is going to be 7 feet minus, right, it's to here, so I'm going to subtract this out. I've got to subtract the X out from either side. And my width is going to be the same way, 3 minus 2x. So that's my starting point, and we've done this before, so that part should not be new. Once I've done that, I'm going to use this to get my equation. And I'm going to keep my 6 equal, and I'm going to use FOIL to multiply all this out. 21 minus 6x minus 14x plus 4x squared. I'm going to combine like terms and get 6. And I'm also going to put this in descending degree and put the 4x squared term in the front and the numbers in the back. So 4x squared minus, let's see, did I do this right? Negative 6x. Yeah, minus 20x plus 21. Okay. I am going to now subtract out the 6 and put it at the end. And I'm also going to flip it and set this equal to 0. Actually, let me do this in 2 steps so I don't confuse you. So first, I'm just going to add, I'm going to keep 0 equals here. Just ignore what I just said. I'll flip it later. And I'm going to subtract 6 from both sides, right? Negative 6 to make it disappear, plus negative 6. I'll put that in red, just so you can see that this is an add-on. And we're going to get 4x squared minus 20x plus 15. Now I'm going to flip it to something that's more comfortable for me and set it equal to 0. Now, I did it this way and did an extra step the book didn't do because in real life, you're given a problem like this on a test, you would be thinking, what's my toolbox? Do I graph this to find the x values? Do I factor? Well, this looks kind of hard to factor. Do I use square roots? Well, I have this b term. That's not possible. My next option, do I complete the square? Well, at first it doesn't look very likely because I have a 4 in front. And normally that's would say that I shouldn't use complete the square. But because this is in a chapter about completing the square, pretty sure that it will somehow work out. Again, completing the square is longer if you have, it's not that you can't do it if you have a coefficient in front. It's just, as you can see, and we have to start by dividing by 4, you're going to get one of these terms is going to be a fraction, and sometimes it's a bit messier. You will see in 10.6 that you'll take something like this and use the quadratic formula. But right now we're going to do this by completing the square. So let's divide everything by 4. And when I do that, I get x squared minus 5x plus 15/4 equals 0. Well, my normal thing for completing the square is set it up. So set up for completing the square. What do I mean by that? I mean, make sure that you leave your blank so you don't make a mistake. So x squared minus 5x plus, here's the spot that I'm going to put my c. And I'm going to move this 15/4 over right here to negative 15/4. And again, add a space where I'm going to add my c. Okay? So what did I do? I really did 2 steps in one, and I apologize. I should have done it in 2 steps. My first hidden step is I subtracted 15/4 and moved it over here. Okay? My second step is I just made sure I added blanks so that I'm ready to find my c value. Okay, well, what's my c value? Well, c is b over 2 squared. So if my b, I'll do this in a slightly different color. Actually, let me put that in red. If my b is negative 5, well, b over 2 is negative 5/2. Well, I know that c equals b over 2 squared. So c is going to equal negative 5/2 squared, which is going to equal 25/4. So I can now backtrack and add 25/4 here and 25/4 there. That was a little more messy than I intended. That marker is thicker than I thought. So let me put it overlay it in blue so it's a little bit clearer. So now I have my equation, x squared minus 5x plus 25/4 equals, and if I have negative 15/4 plus 25/4, I'm going to end up with positive 10/4. Well, I can, because I've now made this into a perfect square trinomial, I can now set it up. X minus, remember, b over 2 is what's going to go in here, and that's minus 5/2. And that's going to equal 10/4. Now that I've gotten to that point, I'm going to take the square root of both sides. When I do that, I'm going to end up with x minus 5/2 is equal to, and I'm just going to reduce it because this is equal to the same thing as, right, I divide both by 2, and it's so it's going to be the same thing as the square root of 5/2, and it's the positive or negative square root. So x minus 5/2 is the positive negative square root of 5/2. all I have left to do now is solve for x. I'm just gonna put a little box here to give myself a little space to finish solving this problem. So bringing this over here, that means x is two things. It's either equal to 5 halves plus square root of 5 halves, or it's equal to 5 halves minus the square root of 5 halves. Okay, it's either 5 halves plus the square root of 5 halves or 5 halves minus the square root of 5 halves. Well, if I do that, the square root of 5 halves, well, 5 halves we know is 2.5, right? So if I have the square root of 2.5, that's 1.58, right? And if I add it to 5 halves, which is 2.5, so plus 2.5, I get 4.08 for my first answer. Okay, going back for my second answer, if I have 1.58, right, and I have 2.5, well, I'm going to go back and get 2.5. I'm going to start with 5 halves over here, so 2.5, and subtract the answer to that, which is 1.58. Sorry, I'm doing this backwards. Let's start again. 5 halves is 2.5. Minus 1.58. Yeah, but that's not correct. Stay with me 1 second. Let me go back and see the square root of 5 halves. 5 divided by 2 is 2.5. Square root of 2.5 is 1.58. 2.5 minus 1.58. Ah, there we go. I don't know what I did wrong. All right, 2.5 minus 1.58 is 0.92. All right, sorry that this was convoluted, but it is important to work these things out. So these values are supposed to be in feet. And I only say this because we now need to determine whether this answer makes sense or not. Should this border, now that we've found, should this border be 1 foot or should the border be 4 feet? Well, it makes a whole lot more sense for this border to be 1 foot or close to 1 foot, 0.92. So we now know this cannot be an answer, because if this border were 4 and 4, the combined border itself would be bigger than the door itself, right? So 0.92 does make sense because you're talking about if it's about 1 foot plus 1 foot, and this is about 5 feet, that makes sense. So if we convert that into inches, right, because the question asks find this to the nearest inch, so 0.92 feet times 12 inches is going to give us 11.04 inches, but it says to the nearest inch, so 11 inches. And that is going to be the answer to this problem. Okay, so this is a long problem. I'm not going to give you a lot of these, but it is important to know how to do them. I hope you're doing well, and I will give you some optional problems to put up next.